Hello, math students. This is your lesson 43 notes, and I hope you've got your notebook ready to go. Lesson 43 notes. Make a note in your table of contents that we're ready for lesson 43. We'll be starting on page 120 today. Lesson 43. You can pause this video at any time if I'm going too fast, but I'm going to try to make the video fairly quick today. It's a long lesson, and as you can see, we're doing this on Monday, April 13, 2020. Again, still in quarantine, away from school, so we'll do the best we can here. Our lesson today is on converting decimals to fractions, then converting fractions back to decimals, and converting percents to decimals as well. If you were in your textbook on page 309, you'll have a little explanation of the very first thing we want to do, which is converting a decimal to a fraction. And maybe that's too zoomed in. We'll give it another try here. So they give you the example of the decimal 0.125, and they want you to turn that into a fraction. Well, I'd like to point out that if we just read this decimal number, we have the tenths, hundredths, thousandths place. So this would be read 125 thousandths, which is written as 125 over 1,000. And I'd like to point out that there are as many zeros as there are places behind the decimal point. So that gives you a little bit of a clue as well, right there. But this fraction is way too big. It needs to be reduced. We never leave a fraction this large. So you could say, well, it ends in 5 and 0, so I know it's divisible by 5. And you could go through the whole process of dividing by 5. But let's use another skill that we've learned, greatest common factor, and see if we can reduce this. So if we take the greatest common factor of 125 and 1,000, we're going to start with 125. And I can see right off the bat that 125 would probably be reduced by, oh my goodness, let's take 25 out of there, shall we? 25 goes into 100 4 times and another one, so that would be 5, and 5 is prime. And 25 is 5 times 5, which is both prime. So 125 comes out to be 5 times 5 times 5. Now let's do the same thing for 1,000. Well, right off the bat, we have 100 times 10, and 10 is 2 times 5, both of which are prime. And 100 is 25 times 4, which would be 5 times 5, and then 2 times 2, all of which are prime. So the 1,000 is going to be how many 2's? 2, 2. We have 2, 2, 2. And how many 5's? Okay, now, if we're looking for the greatest common factor, I see that we have 3 5's here and 3 5's here. So what do they both share in common? 3 5's, which happens to be 125. So if I were to divide both top and bottom by 125, on the top would be 125 divided by 125 is 1. And if I were to divide 1,000 by 125, what I have left is 2, 2, 2, which is 4 times 2, or 8. So the fractional conversion of this is 1/8. And yes, of course, you could have gone through all the division and dividing by 5 and 5 and 5 and 5, but this actually, the greatest common factor, first of all, is something you need to have practice doing. It will help you reduce all sorts of fractions, and for us and this application, it was the easiest. I'm moving on to page 310. And we're going to look at Mattia riding her bike 11.45 miles to the lake. All right, and we want to write this as a mixed number? Well, right off the bat, if I were to read this, it's 11 and 45 100ths. So I've got 11 and 45 over 100. So, but I have to reduce this, right? That has to be reduced. Again, if we were to take 45 and find the greatest common factor there, most everybody would figure out that it's 9, or 3 times 3, 9 times 5. And if we take 100, that's 10 times 10, or 4 times 25, which are squares. So you have 2 and 2, and 5 and 5. So the greatest common factor, it looks like, is simply a 5. So if I reduce this by 5 on top and 5 on the bottom, I'm going to get 9 on the top, and 10 times 2 is 20 on the bottom. You should all know that 5 goes into 120 times, and this cannot be reduced any further. So changing 11 and 45 hundredths of a mile to a mixed number, we cannot forget the 11. It will be 11 and 9 twentieths of a mile. And that's how that one works. All right. Simply enough, if we took a fraction and convert it to a decimal, let's just do a very simple one, 1/4, and convert it to a decimal, the pattern goes something like this. The division bar right there means divide. So you're actually taking 1 and dividing by 4. Well, looks a little weird. 4 does not go into 1. 4 goes into 10 2 times, with how much left over? Bring down that 0. And 4 goes into 20 5 times. This should be one that you would memorize, that 1/4 as a decimal is 0.25. or 25 hundredths. Now, if we take 1/3, how would that look if we try to change it to a decimal? Again, we're going to take our 1, divide by 3, put our decimal up in a couple of zeros. 3 does not go into 1. 3 goes into 10 3 times, which is 9. Subtracting, leaving 1, bring down the next 0. And right away you saw our lesson from last week, which is this repeating decimal idea. Boy, that does not look good, does it? Let's clean that up a little bit so our notes are clear. Okay, so we've got our 3 going on again, and it's just going to continue on and on and on. So we would write this as 0.3 with a repetend over the 3. Don't write it as 0.33 and a bar. Just where it first starts repeating, that would be your answer. Okay, so now every fraction of a whole number will convert to either a terminating decimal or a repeating decimal, like what we have up here, terminating or repeating. Okay, let's draw a little dotted line. And at this point, I'm merging on to page 311 in your textbook. We're talking about probability, which, as you know, is a ratio, which is a fraction as such, but can be converted into a percentage as well. So we have on page 311 a spinner. And that spinner has things divided into fifths. And of course, mine are not going to be equally divided here, but you'll get the idea. And we have 1, 2, 3, 4, and 5 on this spinner. And let's say our spinner happens to land right there. Okay. It says, what is the probability of it stopping on 5? Stopping on the number 5. Well, how many probable answers are there? There are 5 choices, okay? And one chance out of the 5 is a 5. So we have 1/5. This would be our ratio. It's a 1 to 5 ratio, or 1/5. But we'd like to have this as a decimal. Do you remember what 1/5 is as a decimal? Okay, there's a couple of different ways to do this. We can take, like we've done up above, 1 and divide by 5, which you'll know right away comes out to be 2/10. Another way we can do this is 1/5 is equal to how much, if we're doing as a decimal, that would be a part of 10. 5 goes into 10 how many times? 2. 2 times 1 is 2. Now this is a fraction they want as a decimal, so you have to remember that 2/10 is written as 2/10. So the division will actually give you the decimal. This one you will have to then convert it to a decimal. Either way, that's how those are done. Probability. What is the probability the spinner will stop on 5? And remember, when we write that, we're going to write the probability of getting a 5 is 1/5 or 0.2. Now this is going to be a little more significant later on as we change these decimals into percentages. All right, let's turn the page and go on to page 121 in our math journal. Again, we're going to write the page number at the top. We're going to write lesson 43 continued. And we're still on page 100 or 311 in our textbook. All right, the next example, example 4, says write each of these numbers as a decimal number. And I think at this point you should be able to figure these out. We have 23 out of 100. We have 7 over 4. You can see that's an improper fraction when the top number is larger than the bottom, when the denominator, let's see, the numerator is larger than the denominator. What are we going to do if we have a mixed number, 3 4/5? And what about the fraction 2/3? This is A, B, C, and D. All right, right away, 23/100 should be easy for you to convert to a decimal number. If we're dividing this by 23, we simply take the 23, where the decimal point is here, and we're going to move it the number of zeros in our 100. So now the decimal point will be there. You absolutely must have the placeholder 0 out front. So our fraction, 23/100, can be read as this decimal, 23 in the 10/100 place, 23/100. A little bit trickier when we're talking about 7/4. 7/4. If we were to take 7/4 and try to turn it into a mixed number, 7/4 would, right off the bat, become 1 3/4. And many of you would recognize the 1 3/4. If I have 3/4 of a dollar, how many pennies do I have? I have 75 cents. So this would be 1.75. But I want to show you the other way to do this so that you caught on to that too. Anytime the top number is larger than the bottom number, you're going to have a whole number here. And in this case, it's 1, but it could easily be 2 or 3, depending on what the top number is. Again, if we take 7, let me put that down a row. 7 and divide by 4, because this is a division bar. Put our decimal point in and a couple of zeros. 4 does go into 7 one time. With 3 left over, bring down the 0. 7 times right there, which is 28, and 2 left over. And remember, we're going to continue until it either terminates or repeats. So you don't quit, you just keep going. 4 goes into 20 how many times? That would be 5. And at this point it terminates, so we have our decimal number, 1 75/100. Okay, this was A, this was B. Moving on to C. C is 3 4/5. fifths. Well, we just learned that if the top number is larger than the bottom number, that we're going to have a decimal number that contains a whole as well as a part of a 100. So a couple of ways you could do this would be to take your mixed number and turn it into an improper fraction, which will give you a whole lot of stuff to divide by. My preference would be to keep that whole number at our decimal point and then do the division of the fraction, 4 divided by 5. And that's the way Saxon's going to show you to do it as well. Keep the whole number. 5 does not go into 4. 5 does go into 48 times, and look at that, it is terminating right there. Here's our decimal number right here. We've already got our decimal point there, so it's going to be 3 and 8/10. I hope you saw that. That's not too hard, I hope. Works out very nicely. Letter D, we have 2/3. All right, let's take our 2 and divide by 3. Decimal, couple of zeros. 2 does not go into 3. 3 will go into 20 6 times, which is 18. Wait a minute, we got a 2 left over again. Shall we bring another one down? Goes in there 6 times. Well, what do you think of that? We're repeating already. So what will we write this as? 2/3 is equivalent to 0.66? No. As soon as it starts repeating, we know what's repeating here. We put the repetent over that. Please make sure you're not putting the bar over the 0 and the 6, or that would be 0.606060, and that's not at all what we have. All right, I'm going to draw a line here. We have since moved on to page 312, if you're following along in the textbook. And we have comparing fractions and decimals. And in this case, we're taking 3/10 and we're going to compare it to 0.3 repeating. 0.3 repeating. So this is going to require us to do some conversion, and the easiest way would be to convert this to the decimal. So 3/10 can easily be written, guys, I hope you even hear it, 3/10. And this one then is 0.3 with a bar over it, which means we're going out and continuing on. So if I bring enough zeros here, obviously which one is larger, 300 or 333? Obviously, our 0 and 3/10 repeating is the larger of the two when we're comparing. All right, a little bit more here, and then we'll be done with today's class. I'd like you to remember that the word percent, which is one word, means per 100. Or out of. Boy, it would help if I could spell today, huh? 100. Too much Easter candy. Actually, I had one Cadbury egg. That's all, with a creamy center. Per 100. So if I said 75%, I'm actually saying 75 per 100. P-E-R, not P-U-R-R like a cat. 75 per 100. And you could then write this as a decimal. 75 hundredths would be 75 in the tenths hundredths place. So that's not hard there at all. Likewise, if I say 5%, I'm talking about 5 out of or per 100. So 5 100ths would be written as a decimal. 0. There's the tenths place. Here's the hundredths place. 5 100ths. Okay, notice 5% looks like this as a decimal. We're going to be making these conversions, and you're going to want to be very clear on that. Also, there'll be an IXL assignment coming up where you're going to have to make these, and I had to confess I had to do it. I kept getting kicked back lower percentage when I did the IXL because I messed up. So you be careful and be smarter than me. All right, here's example 6, which is on page 313. And we're going to write each percent as a decimal number. All right, so letter A asks us to change 25% to a decimal number, and I think they've given you that fairly easily. 25% we know is 1/4 of something. So 25% of a dollar is 25 cents. So let's look at this. How would you write 25 cents? Well, you'd write it $0.25. But if I have 25 over 100, 25 over 100, 25 per 100, I write that as a decimal 0.25, with the 5 being in the hundreds place. Here's another little trick. How many zeros do we have down here? 2. So take 25 and move the decimal point. You're dividing by 100. Move the decimal point 2 places backwards. So 25 divided by 100 moves our decimal point there. And technically, that's just how I think about it. It's not necessarily correct. Here's letter B, 125%. Well, 100% comes out to be 1, and the 25% is 0.25. Can we assume that this then would be 1 and 25 as a decimal, just 1 and 25. We're not adding the percent sign to it, remember? Okay, so again, this little sign right here means per 100. So the step I skipped is 125 over 100, remember? And if we divide by 100, we're moving the decimal point 2 places. Dividing by 100, moving the decimal point to here, so that would be 1.25. So here's our answer for A, and here's our answer for B. Let's try C. C is 2.5%. 2.5%. Oh my goodness. Well, the 2 is a whole number. And 5%, my goodness, what will that be? Let's see, if we're going to take 2.5 and divide the whole thing by 100, then we're moving this decimal point, dividing it 2 places. So we're going to put 2 and a 5, and let's move this decimal point. Dividing makes it smaller. 1, 2. So I'm going to have another 0 out in front and a 0 there. So we've moved it from here 1, 2 places. So this is our decimal number, 0.025. That one was a little bit tricky. But if 25% is 0.25, and if 5% brings the 5 down to the 100ths place, then 2 would be similar to this, and that means that 2 would be in the hundreds place with the extra decimal. So again, this little thing means divide by 100, so you're moving the decimal point 2 places. If that makes sense, I hope it does. Okay, letter D asks us to take 50% and change that to a decimal. Again, that's going to be 50 divided by 100. Now what's different about this one is that I think you can see this should be reduced, shouldn't it? Well, maybe not. 50 divided by 100, we're going to move the decimal point 2 places. Okay, if we were going to make it a fraction, we would probably reduce it. So this is going to be 0.5. I'm running out of room here. Moving the decimal point 2 places, 0. I did the exact same thing. Okay, 0.5. 0.5. And again, we're taking a percent and turning it to a decimal, so don't add the percent sign. A lot of times kids want to put a percent sign on it. It's not. It's not like converting feet to inches or anything like that. Once we convert it to a decimal point, you don't change anything. Letter E, and I'm taking a lot of time. I want to move on here. What if I've given 7 1/2%? Well, the first thing I want to do with this one is write it as a decimal number over 100. So this would be 7 1/2 is 7.5 over 100, because that's what this is. And then we're going to divide by 100. So we're going to move our decimal point, make the number smaller, move our decimal point to the left 2 places. Have our place value here. We're going to move it 1, 2, so we're going to have a 0 in front of it, and 75. There is our decimal there. So again, 7 is kind of like the 5, so it's going to show up in the hundreds place. And this half is like 0.5. So there we have that one. One more, letter F. If I have 300%, that would be the same as 300% divided by 100. And my goodness, how many times does 100 go into 300? It goes in exactly 3 times. And in this case, 3 is considered a decimal number because we've got the invisible 0 after the invisible decimal. So 3 would be the correct answer there. All right. Be sure you get all of your notes copied. And our magic word today, oh my goodness, what did I say the magic word was? I may have to go change my answer on the quiz. The magic word is going to be, chocolate bunny. Chocolate bunny. All right. Thanks, guys. Bye.